This is Publio Beltrán from TSI Spain. We are representing a company dedicated to the solving noise and vibration problem in the marine sector, and also we are belonging to the Spanish delegation. My question is for Mr. Changubai, related to his very interesting presentation, but it's clear that this presentation is well aligned with the main target or the main challenge of the low noise share project related to the generation of one system that enables to monitoring, in continuous monitoring, real-time monitoring condition of the underwater radiated noise. In this concern, I invited to you to visit the poster of this project because it could be interesting to change opinion with you. My question to you is the following. You are talking about the continuous monitoring of the underwater radiated noise. In this concern, what do you think about the continuous monitoring of the cavitation condition of the propeller in this process? Thank you very much.
Yeah, thank you for the very interesting and futuristic question. And as I mentioned earlier, right now, there are a lot of ship owners try implementing the conditional monitoring system to understand their vessel performance. And I think for right now, mostly focus on the fuel consumption and vessel optimization and the route optimization. And when we try to understand real-time monitoring system, it's about all the sensors are connected and the information is feeding to the captain. So I think definitely the URN should be the part of that monitoring system, and we understand that how can we measure the URN on board. So there is a direct method and indirect method, and as you pointed out, so far, BC Ferry actually tried the indirect method, which is to put the accelerometer just over the propeller blade inside of the hull and measure the pressure level and convert into the URN level. So that is an indirect way. But however, we are not so happy about that, and because of that, a lot of the operation issues and the cavitation issues. So I think it's definitely better to directly measure the URN number and feed to the captain. And another thing which I would like to mention is that whatever we monitor and measure, it is not working until captain knows what's going on in his or in her vessel. So monitoring is the first, but how to feed that information precisely and concisely to the operators, that could be another issue. So BC Ferry is working on to implement that idea. So I will visit your poster and let's make a good conversation between two organizations. Thank you.
Thank you. We're going to take Japan online.
Publio.
Okay, good morning. This is Publio Beltrán from TSI, Noise and Vibration Consultant, Spanish Noise and Vibration Consultant. First of all, congratulations to all the participants of this group. And I have two critical questions. Sorry to be a little bit unpolite in this case. The first one is for Dimitri and also for the person of DMB, Oysten. It's clear that the prediction simulation of the underwater radiated noise by the propeller is a very powerful tool in order to predict the underwater radiated noise, including not only the propeller, but also the machinery. But it's very useful tool. Congratulations for this. But for me, the key question is, it's clear, as Dimitri said, the cavitation is a complex phenomenon. But it's very difficult to get a very right simulation. In this concern, my first question to all of you is, what do you think about the need to validate the cavitation behavior using, for instance, one non-intrusive cavitation detection system that was presented by our company here in this facility in April? But this could be the right validation of the simulation to provide sustainable information about the behavior of the cavitation in different weather conditions and operation conditions. So what do you think about the use of this tool, of this system, to validate the simulation calculation? And the second question is the unpolite question. It's mainly focused for DMB as other classification society. It's clear that related to the harmonization, we have getting very significant progress in the harmonization of the measurement, underwater measurement procedure. But what about harmonization about the limit for the different classification society? Because all the classification society agree that the limit related to the fishing reserve vessel are the same for all the classification society, but the limit for the rest of the ships are completely different. I believe that in order to avoid confusing scenario for the owner, it could be very critical to get harmonization of the limit of noise for the different type of ship. Thank you very much for your question.
A two for Priya. You want to go first?
Yes, I will answer the polite question, and then the DNV will answer on polite questions. So, speaking about validation, you're absolutely right. So, validation is a critical part of any simulation points. And at the moment, there is no, let's say, publicly available validation data to compare the underwater radiated noise and understand whether your prediction is correct. But at the same time, the industry is actually working on that. So recently, it was like a few research projects which specifically were focusing on the performance prediction. So now there are publicly available cases where like anyone can just get their data and simulate the prediction of the performance, propeller, resistance, power, and so on. And we do believe the next phase, the logical phase, would be developing the publicly available data set for underwater radiated noise validation. But as you know, it's not easy because it's required the agreement from the propeller designers and hull designers to share the data in the public domain, which is not easy. But we are working on that, so hopefully we'll have these validation cases as soon as possible. And then I will pass the unpolite question to Austin.
Yeah, and I can also follow up on on the first one as well, that we are at least doing several propeller calculations as well, and then we would always kind of feed that output into the the experience that we're building internally. So we will always kind of have an iterative loop where we try to do a correlation study when we do a propeller study and measurements. Then we get the full scale data, and then we would, of course, correct our methodology going forward and implement that in our standard procedures. And also regarding the non-intrusive cavitation detection system, I think that's a very good system, and it's similar to what we have also developed in DNV. The difference is primarily that we are using a pressure sensor, so we're actually measuring the pressure emitted from the propeller. I think getting data from off-design conditions is also very, very valuable. And it can also support further development of our standard methodologies in propeller calculations and so on. Getting to the non-polite question, I arrived a bit late, unfortunately, yesterday, but I heard it was a question already yesterday. But it's something that we're working on. There was a great initiative by, I think it was Transport Canada or the ECHO program a couple of years back with the harmonization, where we carried out several workshops. So we appreciate that effort. And I think it's also a great step forward with the publication of the ISO shallow water method. So I think having standardized measurement methods is a great step forward, and would also enable us to do further potential alignment. But it's maybe a long process. Yeah. Thank you.
Thank you. Go here.
Metis, really?
As well, and how that kind of fits into this. Thank you.
Thank you, Canada.
Sorry for this. Okay. Sorry. The first question is related to the design, improvement in the design based on this experience with the new propeller. It's very difficult